Hello dear, in this video we will study about the molality, and this is a sample question number 2. What is the molality of 5.00 gram of diiodomethane, which is CS2I2, dissolved in 1.00 liter of ethanol, and the density of ethanol is given 0.791 gram per ml. So to solve this question, first we have to remember the molality formula, which is molality of any substance or of any solution is equal to mole of solute divided by kilogram of solvent. So here solute is this diiodomethane and solvent is ethanol. So I just summarize here. This formula is small m is equal to small n divided by capital W. So from now we have to find out first what are the values are given in this question, and then we will solve this question. So I already solved here, and we will go from left top to bottom on each step, and then right side top to bottom. So first information is given here that mass of diiodomethane 5 gram, which is small w, and capital V is volume of ethanol 1 liter, and density of ethanol is 0.791 gram per ml. So using these values, first we have to calculate that how many moles of diiodomethane are dissolved, and this information we can get it from 5 gram of diiodomethane. And if we remember the formula for how to calculate moles from the gram, which is number of mole is equal to mass in gram divided by molar mass. So mass of solute is here 5.00 gram, and molar mass of diiodomethane is 267.84 gram per mole. So basically for molar mass you have to add carbon and 2 hydrogen and 2 iodine atomic number all together, and then we will get the molar mass. So when we will divide these two values, the gram unit will be cancelled out, and answer we will get in mole. So then in this way we can calculate the number of moles of solute, which is 0.1867 mole. And then second step is to calculate the solvent in gram. So how we will calculate the solvent in gram? Since the density of ethanol and volume of ethanol is given in this question, so we will use these two information to find out the mass of solvent in the kilogram. So D is equal to capital W divided by V, and then we can calculate the mass. Capital W is equal to density multiplied by volume. So density we have to place this value 0.791 gram per ml, and then multiplied by volume, which is 1 liter. Since this is in liter and gram per ml, density is in gram per ml, so we have to match the units first. So we have to convert this liter into ml. So how we can do it? We have to convert this liter into ml by this conversion factor, 1000 ml per 1 liter. So now we can cancel the liter and liter unit and ml units. So when we will calculate this numbers, we will get the answer in our mass of solvent in 791 gram. But for molarity we need the solvent in kilograms, so we have to multiply once again with this another conversion factor, which is 1 kg have 1000 gram, then we can calculate the capital W in kilogram. So when we will divide 791 by 1000, it will come 0.791 kilogram. And then, so this is the second value which we were looking from the question, and now we have to add these two values. Number one is mole, and number two is mass of solvent in kilogram. So we have to use these two values and put this in the molality formula. So molality is mole of solute, which is 0.01867 mole, and divided by volume mass of solvent in kilogram. So when we will calculate these two values, it will come that the solution molality is 0.0236 mole per kilogram, or we can write like it would be 0.024 mole per kilogram, or the solution molality will be 0.024 molar solution. So in this way we can calculate mole and kilogram of solvent if the gram quantity and volume and density is given in the question. So we will see another sample question in next video.